So now we are going to solve the A problem of Codeforces round 988 div 3. So in the problem, it is said that Kinich wakes up to start of a new day. He turns on his phone, checks his mailbox, and finds a mysterious present. He decides to unbox the present. Okay, Kinich unboxes an array of in integer. Initially, Kinich score is 0. He will perform the following operation any number of times. Select two indices I and j, okay, such that I not j has been chosen in any previous operation and a of I equal to a of j. Then add 1 to his score. Output the maximum score Greenwich can achieve after performing the aforementioned operation any number of times. Okay. So first line will be given the test cases, t the number of test cases. The second line will be in the length of the array. Then the following line will be given the array elements of the array. For each test case, output the maximum score available on a new line. So basically the problem says that we will be given an array of integers. Okay, we have to just choose some indices. Okay, we have to just choose some indices which indices are not selected previously, and the value of the that two indices will be same. Okay, then after that, if the value of the two indices which is not previously selected are equal, we will add 1 to our answer. Okay, we will add 1. Okay, then this is also previously selected. Then suppose this one and this one are equal. Okay, we will just add 1. Then this value and this value are equal. We will mark this 2 and we can add our answer. Okay, and suppose this value are equal. We can mark this 2 and add one our answer. Okay, so like this we have to just perform this kind of operation. It is pretty simple that uh, let's break down one of the test cases, then the intuition will be very clear to everyone. So this is these are the value, the last test case. The given value is 6. Okay, and we can just select this index and this index and mark these two indexes and add 1 to our answer. And we can just select this index and this index, mark these two indexes and add 1 to our answer. Then we can just select this index and this index, mark this index, add 1 to our answer. So basically the intuition is uh, in an array, every single element has a distinct indexes, obviously always. If 2 is coming 4 times, then the indexes are always be distinct for each and every 2. Okay, so if we are just selecting one index, we are not selecting one more time. Okay, so in this case, uh, we can just take what I said, that if there are multiple value in an array, then each and every element holds a unique index values. Okay, so we can just count the number of pairs of a same value. Like if we have 5 2s in an array, okay, and each and every two has a unique index. We can select this two, okay, or we can select this two, okay. Else we can select this two and this two. And one will be not selected because there is no another two which can make pair with this two. Okay, so the solution will be the number of values by 2. Like in an array we have 5 2 3 3 6 6 5 and 2. So this 5 and this 5 also are same value, and index obviously this index are unique and not selected previously. And we can just select these two values, and we can just select this two, and we can this two and this two. So like the number of the values 5, we have 5 2 times, We have 2 2 times. We have 3 2 times. We have 6 2 times. We have to just divide the number of count of that particular value by 2. We'll get 1 by 2. We will get 1 by 2. We will get 1 by 2. We will get 1. In the previous case, if there is 5 twos, okay, 2 will equal to 5. Okay, we will we just have to divide 5 by 2. Then we will get the integer division of 5 is 2. Okay, like we can just make two pairs. One will be always there will be 1 2 left. We can which cannot make a pair with another 2. Okay, so this is the simple intuition. Let's see the code. This is the first value, the a problem. Sorry, this is the first problem of the if they contest. This is pretty simple. So I just take the input, just taking the element and counting the number of that particular value through a map, and just iterating through the map, and just sorry, iterating to the array, and just counting the value of that, counting the value, counting that particular value. Okay, like imp of 5 will be if there is 5 2 is available. If e is 5, then 5 by 2 will be I just take a extra line here. Like this else, there is no needed of this extra cells. Okay, we can just take the integer division of that particular value. Okay, just take the integer division, and we can just here directly write this, and we can just initialize MPF equal to 0. There is no need to take the if condition. Okay, at the contest time, I was thinking about another logic or another mm, like at the time of the contest, I think I thought it more about the corner cases, so I implement like this. So you can just remove this if else condition, you just write answer plus equal to mp of e by 2, and lastly print the answer. So this is the uh, a problem solution. So now let's see the b problem of the this contest. So to help you prepare for your upcoming Codeforces contest, uh, whatever the name is, set a grid problem and is trying to give you a in an n by m grid. So your input stream, especially your input stream should contain the following. First line contain two integer n and m, the dimension of the grid. The following in line contain m integer, the value of the grid. However, someone has interrupted your input stream, shuffled all given integer and put them all on one line. Now there are k integers all on one line, and you don't know where each integer originally belongs. Instead of asking the name, whatever it is, uh, what it seat lali or something, seat lali, yeah, seat lali, to uh, resend the input. You decide to determine the value of in and m yourself. Output any possible value of in and m that Sitlali could have provided. The first line will take an integer t, the number of test cases. The first line of each test case contains an integer k, the total number of inputs in the input stream. Okay. Following line contains k integers. Shuffle input of your input stream. Get it that n and m are contained within k integers. Okay. Okay. For each test case, output to integer one possible value of n and m if multiple possible answer exist any of it. So like basically the problem says that we in the input stream I will be given to integer the dimension, like the dimension of a grid. Okay, the dimension of a grid. So like this is the dimension of the grid, and the value of the grid, like 4 into 2, the value will be so the grid is two row and four columns. Okay, two row and four columns, and there will be given eight values. Uh, eight values. So these dots are suppose here is the value. Again eight values. So someone just after the someone just interrupt our input stream. So the values and this dimension are mixed into our input line. Like there will be some values like 8, 4, 3, 1, 5, 10, 1, 2, 3, 4, 5, 6, 7, 8, and 2, 4, and 9. Okay. Someone just interrupted like our input stream. So we have to just find the value, the dimension of our grid. Okay, if there are multiple solution, we can just print any of them. Like here is a possible answer. We just we can choose two rows and four columns. After that, eight value will be left. If we take this dimension, after that there are eight value left. We can see that clearly. One, two, three, four, five, six, seven, and one eight. There will be eight value left. Okay, so just we have to just find the dimension of our grid, which can hold which dimension can hold the left values. Okay, so if we break down one test case, this will be more clear. Let's take the second test case. So in the second test case, they are given this. So we have total 11 values. So we have to just find two values. Find two values x and y. The dimension of the grid which can store 11 minus 2, because x and y will be deleted or removed from here. So there will be value will be let x minus 2 equal to 9. So you have to just a dimension of 9 size. Okay. If we take 9, 3 and 3 into 3. This 2 value will be deleted and 9 value will be left. And the dimension is 3 into 3, which also store 9 values. Okay. So this is a possible answer. So we can see that there is no another answer which can satisfy this condition. Okay. Then we can take the third test case. In the third test case, we are given eight values. Okay, and we have to just find x and y, the dimension. The dimension after finding the two values, there will be 8 minus 2 value left. It means 6 value left. So you have to just find a dimension which stores 6 values. If we take 3 into 2, 3 into 2 dimension, we take these two values. Value will be left equal to 6. 6 value will be left, and this dimension is also 6. So this is also a possible answer. This is a possible answer. Okay. Like in the answer of the third test case, you can see that this is a possible answer 2 comma 3. The order doesn't matter. You can write 3 comma 2 or 2 comma 3. It depends upon you. It doesn't matter. Now after that, the given test case is this. So we have to just find x and y. Deleting these two values, the left element will be the number of left element will be 4. To just find the dimension which store this values. If we take x equal to 1 and y equal to 4, it means 4 into 1. It will store exactly 4 values. So this is a possible answer, 1 comma 4 or 4 comma 1. Yeah. So this is the answer. So hope we all understand what the question is saying. So now we have to just uh, know that how this problem will be solved. So what is the intuition to solve this problem? So intuition is very simple. We take the last test case. Okay. So there is 8 values. Here are 8 values. Okay. This case contains 8 values. So obviously it is clear that we have to store in minus 2 values. So if this is n, we have to store in minus 2 values always. Okay. So here is n minus 2 is 8 minus 2 equal to 6. Here we will have to store 6 values. So we have to just make a dimension which stores 6 values. Like let's take 6 equal to the size or SZ equal to 6. We have to just find uh, the two divisor of 6 is present in it or not. If here is 1, another divisor, if one is also divisor of 6. Okay, it is also divisor of 6. So another divisor of 6 is 6 by 1 equal to 6. 6 is 6 present in it? Yes. So this is also a possible answer. Another we can check also that 6 by 2. 2 is a divisor of 6. Yes, 2 is a divisor of 6. So another divisor of 6 is 3. Is 3 present in it? Yeah, 3 is present. So this can also be a possible answer. Then another 6. If 6 is there, 6 is a divisor of 6. Yes. Another divisor of 6 is 6 by 6 equal to 1. Is 1 present in the array? Yes. So 6 and 1. So this is the previous possible answer. So in this case, we can just uh, uh, in O of in time complexity, like in one iteration from left to right, from the in the array, we can just find directly the dimension of the given 2D array. Okay. Here it is clearly said that apologize for that. If multiple possible answer exist, output any. We can just output any possible answer. Okay. So, so this is the intuition. Let's see the code. So here in the code, I'm just taking input of the element and just counting the uh, number of that particular value. Okay, and just taking the need. It means the size of the array equal to n by 2, like the size of the elements. Okay, if x and y, the two values which denotes the dimension, are subtracted from the total number of values or k which is given, we will be the number of values will be z n minus 2. Okay, so the total number of values by a of I. Okay, if a of I into need, it means equal sz. It means if it a of I need is a divisor of both are divisor of sz, then we can just get into this condition and check a of I if a of I equal need, and then imp of a of I minus 1 is greater than 0. If it means if a of I and need are equal, then the number of that value will be 2. So a of I minus 1 will be greater than 0. Else a of I is not equal to, if both divisor are not equal, then we can just check that the both divisors are present or not, like the need is present or not. Like a of I is present, like we are just iterating with a of I, and need, we're just taking need size is evaluated need from z by a of I. Okay, just finding need is present in the array or not. If it is present, just printing a of I need and just returning from there. Okay, and like here what I check that if I equal to need, like this test case, if this can also happen, like uh, um like there is 2 given in it and another 2 is there, and we have to just find uh, there are 1 2 3 4, there is given 6 values. We have to find a dimension which denote size 4. Okay, like we are here we are having 2, and this is the need. Sorry, this is not the need, this is the AZ. total size, like the dimension, spaces, which we needed. So need is z by a of I. It means 2. Now it is 2. Z by 2. Z by 2 is also 2. So we have to just check that 2 is greater than 2 times. Okay. Greater than or equal 2 times. Like 2 is coming in the array 2 times. So here we just take that. Like yeah, so this is the, like, if a of I equal to need, then we are just checking that imp of a of I minus 1. After subtracting the counter of a of I, it is greater than 0. Okay, so like it is coming multiple times. For a of I not equal to need, we are just finding the need is present or not. If it is present, then just printing the a of I need, the solution. Hope you understand the solution. Now let's solve the problem C. So the problem is given in the problem. This is given that super ultra little red panda desperately wants Primo gems in his dreams. A voice tells him that he must solve the following task to obtain a lifetime supply of Primo gems. Super ultra. Okay, construct a permutation P of lengthen that P of I plus 1, like uh, two consecutive values is composite. Like it is not prime. Composite value means it is not prime. Non-prime numbers. Like it has multiple divisors except one in itself. If it is not possible, output minus 1. Okay. So there is also given the definition if anyone is not related with the permutation. So yeah, the definition given about the permutation. Like a permutation of lengthen is an array consisting of indistinct integer from 1 to n, like in arbitrary order. For example, 2 3 1 5 4. It is a permutation. Like this is a length 5. The length of the array is 5, and there is value from 1 to 5. So this is a permutation, but this is not, because the length is 3 and the value present in the array is not from 1 to 3. Like 2 is coming multiple times. It's not a permutation. And 1 3 4 is also not a permutation, because length is 3 and the value will be 1 to 3, but 4 is coming. So this is not a permutation also. And an integer is a composite if it has at least one other divisor beside 1 and x itself. Okay. For example, 4 is a composite because the 1 and 4 is also a divisor of 4, but as well as 2 is a divisor of 4 also. So in the input will be given the first line contains t, the number of test cases. Each test case contains an integer and the length of the permutation, and we have to just build a permutation p which will uh, satisfy this condition. Okay, if it is not possible, then we can just directly output minus 1. So how can we create such permutation? Like, just understand that in the case if n equals to 3, permutation is 1 2 3. Okay, if we have to create such permutation, two composite two consecutive value will not be a prime number. Okay, if we construct like this, 2 and 3, 1 and 2 is 3. This is a prime number. It is not possible. And 2 and 3 5, and this is also a prime number. This is not possible. If we construct 2 1 3 and 1, this is also coming 3, but 1 and 3 is 4. This is not a prime number, but here it is coming a prime number. So this is not possible. If we construct 3 1 2. This is the same, or 3 2 1. This is the reverse of the this particular first example. Okay, so this is not possible to create such permutation for n equal to 3. Okay, let's see how can we make such permutation for n equal to 4. N equal to 4, permutation will be 1 2 3 4. If we create such permutation, like if we take 4 and 2, okay, 2 4, which is 6, 3 and 1, 3 and 1, which is 4. So this is 6, this is 4, but this is 7. This is not possible. Okay. And if we take 2, 4, 1, 3, this is 4, this is 6, this is also coming 5. So this is also not possible. So for 4, it is also not possible to create such a permutation. Let's see, n equal to 5, it is possible or not. Equal to 5 is 1, 2, 3, 4, 5. For n equal to 5, if we create 1, 3, then 5, and if we take 4 air, 2 air, we can directly create like such a permutation. Okay, so 3 and 1 is 4, 5 and 3 is 8, 5 and 4 is 9. This is also non-prime number, and 4 and 2 is 6. This is also non-prime number, composite number. Okay, so 5 it is possible. So from this we can just observe that if n less than equal 4, we can directly print -1. If it is n greater than equal 5, then we can just create such permutation through our implementation for this particular solution. Okay, how can we build such permutation? How can we just observe? Like, let's take n equal to 7. For 7, we have value 1, 2, 3, 4, 5, 6, 7. Just think, friend, just think about composite number is also always, we can just say that a even number is always a composite number. Even number is always composite. Isn't we isn't we say that? We can always say that it is always true that even number is always a composite number. So if we just target to take even numbers, how can we take even numbers? The sum will be even to consecutive numbers. Like if we split, like if we take odd and odd, if it is prime, it doesn't matter it is prime or not. If we take any odd, any two odd is also prime, then it is always give us a even number, which is also a composite number. We take even plus even, it is also always give us even number, which is also composite number. So from this, if we split this array into two parts, like if we split this array into two parts like this, if we take even numbers here and odd numbers here, okay, the even numbers are here is 2, 4, 6. Like we can take 2, 4, and 6, and the odd numbers are 1, 3, 5, 7. 1, 3, 5, 7. Now look here, friend. Here in the splitted two arrays, the the two consecutive numbers is always composite, isn't it? 1 and 3 are 4. This is also composite. 3 and 5 is 8. This is also composite. 5 and 7 is 12. This is also composite. Okay. This 2 is also composite 6. This 2 is also composite 10. Okay. Now we just have to find a way to merge these two arrays. Like here, if you see that if we merge 1, 3, 5, 7 with this array, like we can just directly merge it 2, 4, 6. Like in this part, the part of the joint, we are also getting a composite number. In this case, 9. This is also composite. So we can directly just add this. In another case, if the array is not 7, okay, let's take another example. Array is the length of 9, okay. So the values are 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the odd values are here and the even values are here. So what are the odd values? Odd are 1, 3, 5, 7, and 9. 3, 5, 7, and 9. The even values are 2, 4, 6, 8. These are 2, 4, 6, and 8. So these are the even values. So in the previous observation, we directly observed that in the set of odd values, the every two consecutive are composite, okay, and the even set of even values every two consecutive are composite. So it is always true. So we have to just find a way to join these two sets. Like here, if we just directly join this two, 1, 3, 5, 7, and 9, and 2, 4, 6, 8. So in this joint, in this point of the joint, we were getting 9 plus 2 equal to 11. It is not possible. So it is not a composite. It is a prime number. So it is not possible in this case to join directly like this. So just think about it. If we just like it is not possible to directly join it. Okay. So if we just iterate here and just compare every each and every value. Okay. So compare each and every value 9 with 4. It is composite or not. 9 plus 4 equal to 13, not composite. 9 plus 6, it is composite or not. 15 is composite. So we can just swap 2 and 6, 6 and 2 like this, and directly join like this, 6 and 2. Isn't it? So this is very easy. This implementation is very easy. Like we will split each and every set in time, and we will just traverse through another loop and just create such an permutation. Like let's finalize with this example. Like if it is 8, we are having a set 1, 2, 3, 4, 5, 6, 7, and 8. So the odd values are 1, 2, sorry, 1, 3, 5, 7. And the even values are 2, 4, 6, and 8. So we can here we are just this is the odd values. So every yeah, consecutive values are composite, and here is even values. Every consecutive value is also composite. So we just compare this value and this value. Adding this to value is composite or not. This is directly composite we are getting. So we just directly merge this with this. If it is not, then we can just traverse through it and just compare that which value adding which value with it is composite. Is getting composite. If it is composite, we can just swap with this two with this value and just directly join this array. Okay. So let's see my code of implementation. Hope you understand the solution. So here is the code. If n is less than or equal to 4, then there is always minus 1. If it is not, I'm just taking to vector odd and even. If it is odd, I am just putting the value in high. Okay. Just from the permutation. If it is even, then just through the ternary operator, I am just pushing the even value to the even array. And I am traversing to the array, okay, even, and just checking that odd value, the last element of the odd list, okay, plus that ith element of the event list is after summing the two values, the uh, last element of the odd list and the ith element of the even list, that it is non-prime or composite or not. If it is composite, then we are just directly pushing the e of the ith value of the even element to the odd array and just marking the index I. After that, directly breaking and uh, pushing each and every element from e of I except the idx into the odd vector. Okay. So after that, just directly printing the each and every element of the odd vector. So this is the solution. Hope you all understand this solution.